Welcome guys. It's nice having you guys on board again today. Today we are looking at motion under physics. And you could recall in our last class, or our last video, we talked about motion. I spoke on the introduction, the types, relative motion, a little bit. Just in case you don't understand that or you're not familiar with that, I'll just implore you to just rush back to click on the video on that introduction aspect of motion. But today we are going to be talking more on relative motion. I'll talk more on relative motion than I did the last time. So when we say relative motion, what are we talking about? I said that it has to do with a motion of a body in comparison with another body. So if a body moves based on the motion of another body, we say that body is undergoing what we call relative motion. And to make it so practical, almost every one of us are involved in relative motion at one point or the other in our lives. Maybe every single day or once in a while. Sometimes you're passing the road and somebody is just right in front of you. Because you don't want to hit the person or collide with the person, what happens is that you just make a different move so that the person can have a free space. That move that you just made is actually a relative motion in respect with the other person that was coming before you. I hope that is clear. Same happens when you're in a vehicle. Just imagine yourself waking up in the morning and you want to drive your car, or your dad is taking you out or something like that, and you were all sitting in the vehicle and he turned on the ignition and began to move the car. If it drives at a very fast speed initially, what happens is that you jerk backward because it was the car that was set in motion, not you. This property of matter that makes you jerk backward is called inertia, and that's why you would not just keep moving alongside the vehicle when the car was started. And when the car suddenly applies its brake, what we have is that what? You move forward while the car stops. So it was the car that actually received the instruction to stop, not you. So over time you balance. I'm just trying to tell you how relative motion plays out in our daily life. But today we're going to do a little bit calculation, or should I say, some simple calculation as touching that. Say, for instance, we have this long vehicle here, and we have passengers here, passenger P, passenger G. So they were all seated. And sitting here means that everybody, and the car is in motion. The vehicle is in motion. Forget the initial jerking backward or forward. Everybody is now stable. If this car or this vehicle was to be moving at 500 kilometers per hour, for example, it means both passenger P and passenger G are all having the same speed as the vehicle, irrespective of the position they took in the vehicle, as far as they are seated on their seats and they're not moving. But if for any reason passenger G decides to move forward to meet passenger G when this car is already set in motion, so we now have P here. Now, and let's say it moves with a speed of 20 kilometers per hour in the vehicle, right, like that. While it's doing that, something is now different. Formerly, P and G were both at 500 kilometers per hour with the vehicle. Now, because P moved forward, P is now ahead of all of the motions, all of the speeds. Let me show you what I'm trying to say. The car is moving in this direction. So if you are moving in that direction, then we say you are adding. If you are moving opposite direction, we are subtracting, provided you are in the same medium, which happens to the vehicle now. Are you getting me? Now, it's a very different ballgame when we are in different medium. But P and G are located in the same vehicle. So this is a case one issue where every movement is within one medium. The medium here is what? The vehicle. So if you move forward, then we have to add your speed. So that means as P moves from here to where G is, automatically this P has a higher speed, which is plus. Sorry, let me use a red marker to show that. So that means P now, which was initially at 500, let me use the word initial. P is 500 kilometers per hour. Upon movement, forward, what do we have? P becomes 500 plus the new speed as far as it was in direction, plus 20. So we have what? 500 and what? 20 kilometers per R. Meanwhile, our G still maintains that. So if you ask who is at higher speed when P moves forward within the vehicle, P is. Are we getting that? On the contrary, if G had gone backward now to meet P, what would have happened is that G, which was actually at 500 km per hour initially, right? That's initial. Would now, upon movement, or upon motion, let me use the word motion now, will become, moving backward means it's a negative, you are going against the medium movement, so you have to be negative. So we have it to be 500 minus, let's say if it's 50, for example, kilometer per hour, would have had 50, and our answer would be what? 450 kilometer per hour. Now, note this, even though they are both at the same position at this point, they were at different speed. So, based on relativity now, this guy is 50 kilometers per hour faster than this guy. So, what will be the speed of P in relative to G? It will be what? 50. Are you getting me? While G in relative to P will be what? Still 50, but negative 50 now. Are you getting me? But in general, if you want to get them based on it from the observer outside, it will be what? 500 here, 450 here, 520 here, 500 here. Is that okay? So that is very clear on that case one. But let's now assume that, okay, before I leave that, when the car was in motion and they were both seated, their speed related to each other was 0. That's why at every point in time, they were always at their position. No difference. So I hope that is very, very clear. Secondly, assuming we have a bike beside this vehicle now. Let's say you have a bike, a bicycle, whatever. Let me just call it a bike, just to make things easier. And then put the bike ahead. So you have a bike. Don't mind my drawing anyways. I'm becoming a little bit artistic. Okay, maybe I am, but then just follow me up and let's just get. Now, let's say we have a bicycle in front of this vehicle, and note that this guy was running at what? 500 kilometers per hour. Are we there? Whereas, let's say this guy was running at 800 kilometers per hour. Now, these are two different vehicles, and of course, there should be a passenger here. Just call it F. Now, the passenger on F is faster than this person. Is that true? Well, the question is this guy 800 kilometers per hour faster than this guy? Of course, no, because they are in the same now. They are not in the same direction now. Watch me. The same direction. The same direction. But because there are two different medium now, we subtract. If you are comparing one medium against the next medium, we what? Subtract. But we are comparing two people within the same medium and they are going in the opposite direction. We what? We subtract. Going in the same direction, we what? We add. So look at what I'm trying to say. This guy is a medium on his own, which is the bike. This is another medium, which is what? The vehicle. So if you put them together now, guy is 800, this guy is what? 500. But if you are comparing this guy with this guy, what will be the difference? We're going to have to what? Subtract. So the guy in F is having a 800 minus 500. So it is faster by what? 300. That means if this guy can increase his stuff by 300 kilometers per hour, he can catch up with this guy. That's why you can overtake a vehicle. I hope that is really clear. And that's pretty simple. So that same principle works. When they were in the same medium, I said as this guy was moving forward inside the medium, he's moving faster. So you have to add. Are you getting what I'm trying to say? You are comparing this guy's movement with the medium that is carrying him. So if he moves forward, it will be faster than the car. If he goes backward, it will be slower than the car. But if you are comparing these two guys now, and one is not moving, it maintains his car speed. So that means this guy, if he's standing alone, he's running the car. I hope we're getting that. Now, that is different from trying to compare two different vehicles that are on their own. If two of them decide to move forward at the same speed, they will still be having a difference of 0. Because they are moving together. So when you are moving together with speed, what you do is what? You subtract. When you are moving apart, you add. If there are two different medium. But if you are comparing a passenger with the medium that was not moving before, if he moves in the direction of the car, you add to know his own particular speed. But to compare their speed now, you what? Subtract. I hope that is really clear. In case you didn't get that, let me say it one more time. I mean that here is the car is the medium. These passengers are here. Everybody now have the same speed. The car, passenger P, passenger G. But if you want to say compare their speed, now is 0. Relative speed is 0. But if this guy moves forward now in the direction of the car, is faster than the car. How do we know his own speed? His own speed, if he goes by 20 km per hour, it will become 520. But if you compare it to the vehicle, it's 20 km per hour faster than the vehicle. Are we getting it? Then, if he's moving backward, because he's moving against the direction of the vehicle, his own speed becomes reduced. And if you compare with the vehicle, is 50 km per hour behind the vehicle. Is that okay? And that's also true if you are comparing two different mediums, or media rather. You are going together. This guy's speed on his own is what? 800. This guy's own is what? 500. Because they're on the same direction. If you want to get their relative speed, this guy is 300 km per hour, while this guy is 0 in the eyes of this guy here. Whereas this guy is 300 ahead. This guy thinks that, okay, I'm 200. You have to add that 300 to himself to get what this guy is. But the relative speed is what? Is the difference between them. And they are going separate way. We have to add that. Exactly? I just hope we got that. So let's try an example. All right, just to drive home the points clearly, because some might not have gotten it so well, I decided to come up with an example. Here's, I guess, a JAMB question, where we are told to unravel the speed of a car in relative to another vehicle. Now, let's see the question. The driver of a car moving with uniform speed of 40 meters per second observes a truck approaching from the opposite direction with a speed of 20 meters per second. Calculate the speed of the car relative to that of the truck. Calculate the speed of the car relative to that of what? The truck. It means that, let's see how we would unravel this. So the car is, let's say the car was coming this way, 40 meters per second. And that's, let's call it car. And the truck approaching this way, 20 meters per second. Now, I want to ask you this question. Are these the same medium or different medium? Obviously, the observer knows that there are two different mediums. So these are what? Two different mediums. So we call this truck. Sorry, let me name this well. Truck. The truck. There are two different mediums. And I said, when a body is moving in the same direction with the other, when it comes to the speed, what you do is what? You simply subtract if they are different medium. But the opposite is true when they are opposing themselves. You add. If you subtract when they are going in the same direction, then you have to subtract when they're what? Approaching themselves. And that's what that is all about. So in this case, we could see opposite direction, you add. So for speed, for relative speed, let me write that out. Relative speed of different medium medium in opposite direction simply add. All right, so I just simply said you add. Relative speed of different medium in opposite direction, you add. So let me give you the converse statement. Relative speed of different medium in the same direction is simply subtraction. So let's go by this and let's see. I think if you look at our question very clearly, it flows with this statement I have just written down there. So what do we do? Get the speed of the first vehicle. What's the speed of the first vehicle? 40. So C runs at 40. Solution right here. 40 meters per second. And your truck T runs at 20 meters per second. I like to put the direction in the opposite way so we can know that it's opposite direction, right? So simply, relative speed is equal to 40 plus 20, and the answer is 60 meters per second. And that's that. And I believe this is so clear. I want to take your time again and go through the video and see this question, follow it through, because it will save you a fortune, especially if you're writing JAMB. See you guys in my next video.